This video is about the response of the nerve to stimulations of increasing intensities. And at the end of it, the student will be able to explain the response of a nerve to stimulations of increasing intensities. The nerve fiber obeys the law of all or none because it doesn't trigger action potential if the intensity of stimulation is less than the threshold of stimulation. In the contrary, it triggers action potentials of same amplitude for intensities that are equal or more than its threshold. Does the nerve respond to stimulations by the same way? Let's see. First, what about the composition of a nerve? The nerve includes different types of nerve fibers, myelinated and non-myelinated nerve fibers, and nerve fibers of different diameters as we see in this document. And each type has its own threshold of stimulation, and it conducts the nerve message with a different speed. What does this composition lead to? Let's see. In this experiment, a nerve is submitted to stimulation of increasing intensities. Using the oscilloscope, we record the response of the nerve. Notice that we are measuring the global potential of the nerve that represents the summation of electric activities of different types of nerve fibers in this nerve. In other terms, if all fibers in the nerve are at rest, the global potential is null. And now let's see the experiment and the obtained results. Let's see the summary of the results. If we consider I as the intensity of stimulation. For intensities less than 20 milliampere, the global potential was equal to 0 millivolt. For intensities greater than or equal to 21 milliampere and less than or equal to 60 milliampere, we obtained a global potential of increasing amplitude. At the intensity equal to 60 milliampere, we obtained the maximum amplitude. And finally, for intensities greater than 60 milliampere, the amplitude remained constant. How can we explain these results? In fact, the origin of these results is the composition of the nerve in nerve fibers. This experiment explains the results. What do we have in this experiment? This is a nerve with many types of fibers in it, and we will stimulate it with 4 different intensities of stimulation. First, when we stimulated this nerve with a weak intensity of stimulation, only one types of fibers responds to stimulation. Now we stimulate the nerve with a moderate intensity, and as we see, 2 types of fibers respond to stimulation. Now let's see what happens if we use the strong intensity. As you see, all fibers in the nerve are now stimulated and activated. What about the very strong intensity of stimulation? Also, in this case, all fibers are stimulated. This is the recording obtained. The green curve is for the weak intensity of stimulation, the orange one is for the moderate, and the 2 other curves are for the strong and the very strong intensities of stimulation, and they are the same. They have the same amplitude. Okay, now in this curve, intensities I1 and I2 are non-effective to stimulate any type of fibers in the nerve. For I3 to I5, more and more fibers are stimulated, leading to the increase of the amplitude of the global potential. And at 5, the all fibers in the nerve were stimulated because after I5 the amplitude remains constant. Finally, in this document, we study the recording obtained upon the stimulation of a nerve as a function of the distance between the stimulating electrode S2 and the recording electrode R1. When the distance between S2 and R1 was 15 millimeter, the oscilloscope records one peak, one global potential. As the distance increases, we notice the appearance of a second peak till we obtain 2 separated peaks when the distance becomes 100 millimeter. How can we explain this result? The appearance of many peaks indicates that the nerve message in the nerve is conducted with many speeds because of the presence of many types of fibers. But the amplitude of each peak depends on the number of nerve fibers that conduct the nerve message with the same speed. So the number of fibers that conducts the message with the first speed is higher than that conduct the message with the second speed.